Good evening everyone. So last class lo మనం Bernoulli and binomial distribution discuss చేసాం and also Poisson distribution యొక్క probability mass function and movements discuss చేసాం and probability movement generating function ఒకటి and characteristic function, cumulative generating function and probability generating functions ఇవన్నీ కూడా and additive property of Poisson distribution and also when binomial tends to Poisson and properties ఇవన్నీ డిస్కస్ చేసినప్పుడు ఈ కంప్లీట్ Poisson అనేది మనకు కంప్లీట్ అయిపోతుంది. అండ్ లాస్ట్లీ probability mass function of Poisson distribution. Probability mass function of Poisson distribution. P of x is equal to e power minus lambda power x and x factorial x equal to 0, 1, 2, 3 so on. And second one, Poisson distribution का mean is equal to lambda, variance is equal to lambda. Third one వచ్చేసి Poisson distribution లో mean is equal to variance అంటే lambda equal to lambda. మూడు ప్రాపర్టీ మనం లాస్ట్ క్లాస్ లో డిస్కస్ చేయడం జరిగింది. And movement generating function of Poisson distribution. Movement generating function of Poisson distribution. PMF of Poisson distribution is given by P of x is equal to e power minus lambda power x and x factorial x equal to 0, 1, 2, 3 so on. And here movement generating function of Poisson distribution is given by mx of t is equal to expectation of e power tx. Expectation of e power tx. Summation x equal to 0 to infinity e power tx into p of x. Summation x equal to 0 to infinity e power tx into e power minus lambda power x and x factorial. You can write e power minus lambda is the constant. Summation x equal to 0 to infinity and e power lambda into e power t whole power x factorial. E power minus lambda of lambda into e power t whole power 0 by 0 factorial plus lambda into e power t 1 by 1 factorial plus lambda into e power t square 2 factorial plus lambda into t 3 and 3 factorial plus so on. E power minus lambda 1 plus lambda e power t by 1 factorial plus lambda e power t and square by 2 factorial plus lambda e power t and 3 factorial plus so on. E power minus lambda generally we have a formula e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus so on. In this equation x is equal to lambda into e power t. So we can write the e power minus lambda into e power lambda into e power t. We can write e power lambda into e power t and minus lambda and e power lambda into e power t minus 1 is a mx of t. Moment generating function of Poisson distribution. Moment generating function of Poisson distribution is given by e power lambda into e power t minus 1. Consider we can find the first moment mu1 dash is equal to d by dt mx of t and t equal to 0 is equal to mean. mu1 dash is equal to d by dt of mx of t ante e power lambda into e power t minus 1 of t equal to 0. So first derivation is e power lambda into e power t minus 1 into lambda into e power t equal to 0. And e power lambda common term e power t into e power lambda into e power 1 and t equal to 0. T equal to 0 ante e power 0 and e power 0 and lambda into 1 into 1 and lambda mu1 dash is equal to lambda. Then we want to find out the mu2 dash. d square by dt square of mx of t and and t equal to 0. Mu 2 dash is equal to first derivation already completion కాబట్టి first derivation కి again we do the second derivation d by dt of first derivation is lambda into e power t into e power lambda into e power t minus 1 and d by dt of e power t into e power lambda e power t minus 1 u and v here lambda into e power t into e power lambda e power t minus 1 and lambda into e power t plus e power t and e power minus lambda into e power t minus 1. T equal to 0, t equal to 0 and t equal to 0. So e power 0 and e power 0 into lambda plus e power 0 into e power 0. That means lambda into lambda plus 1 is the mu 2 dash. That means lambda square plus lambda. Then find out the variance mu 2 is equal to you can write mu 2 dash minus mu 1 dash whole square. Mu 2 వచ్చేసి lambda square plus lambda minus lambda square lambda and mu 2 is equal to variance is lambda. CF of characteristic function of Poisson distribution. Characteristic function of Poisson distribution. Generally, the PMF of Poisson distribution is given by P of x is equal to e power minus lambda power x and x factorial x equal to 0, 1, 2, 3, so on, lambda greater than 0. And characteristic function of Poisson distribution is phi x of t is equal to d by dt of expectation of e power itx. Expectation of e power itx summation x equal to 0 to infinity e power itx into p of x. X equal to 0 to infinity e power itx into e power minus lambda, lambda power x and x factorial. E power minus lambda is a constant term, e power minus lambda summation x equal to 0 to infinity lambda into e power it whole power x factorial. E power minus lambda of lambda into it 0 by 0 factorial plus lambda into it power 1 factorial plus lambda into e power it power square by 2 factorial plus so on. E power minus lambda of 1 plus lambda into it power 1 by 1 factorial plus lambda into e power it square by 2 factorial plus so on. E power minus lambda. So here generally e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus so on. This is the formula, and here x is equal to lambda into it. E power minus lambda into e power lambda into e power it. Finally e power lambda into e power it minus lambda and e power lambda into e power it minus 1. This is the characteristic function of t. E power lambda into e power it minus 1 is a characteristic function. consider mu1 dash is equal to minus I of d by dt of pi x of t and t equal to 0. In this mu1 dash is equal to minus I d by dt of e power lambda into e power I t minus 1 I t minus 1 and t equal to 0. mu1 dash is equal to we can write minus I of e power lambda into e power I t minus 1 lambda into e power lambda into e power I t and I. So in this t equal to 0 and mu1 dash equal to minus I square e power t I t minus 1 lambda into e power I t and t equal to 0. I square is equal to minus 1. So minus of minus 1 e power lambda e power I t x minus 1 lambda into e power I t and t equal to 0. T equal to 0. T equal to 0 substitute say this is a 1 and e power minus lambda into e power I t 0 minus 1 lambda into I t 0 is equal to lambda mu2 dash mu1 dash is equal to lambda. Consider mu2 dash is equal to minus I square d square by dt square pi x of t and t equal to 0. X of t and t equal to 0. mu2 dash is equal to minus I square d by dt of we have a I into lambda e power t e power I t into e power lambda into e power I t minus 1 when t equal to 0. In this constant term lambda is the constant term and minus I whole square. UV method generally e power I t into e power lambda into e power I t minus 1 and lambda into e power I t into I plus and e power t power it minus 1 into e power it into I. These are the values, and here minus square ఉంటుంది and I square ఉంటుంది and lambda. Here minus and minus of minus 1 plus lambda and e power, substitute and ఇక్కడ I lambda అనేది కామన్ టర్మ్. I lambda is a common term and we can write t equal to substitute 0 e power 0 into e power 0 lambda into e power 0 into I plus e power 0 into e power 0 into I into I, and we can write plus ఇక్కడ minus ఉంటుంది and we can write minus I into lambda, minus I into lambda, and we can write lambda I plus I, then minus I square into lambda, lambda plus 1, you can write minus of minus 1, the plus and lambda into plus lambda 1 and lambda square plus lambda. This is the mu 2 dash, and finally mu 2 is equal to mu 2 dash minus mu 1 dash whole square, and mu 2 is equal to lambda square plus lambda minus lambda whole square, lambda square plus lambda minus lambda square, lambda cancel lambda, mu 2 is equal to lambda. This is a variance. This is all about today's class, and tomorrow we'll discuss about accumulating generating function going to discuss there, and this is all about today's class. Thank you so much.